Evangelista here. I'm going to be going over the IB exam you guys took today. Going over paper 1. Okay, how many atoms of nitrogen are there in half a mole of NH4 2CO3? Start out with our half a mole, and let's go to molecules. Remember, we can do that using Avogadro's number. There are 6.02 times 10 to the 3 molecules for every mole. Okay, now in each of these molecules, there are 2 atoms of this nitrogen. And so I multiply by 2. So if I multiply by half and then multiply by 2, I go back to Avogadro's number, so D. Okay, this one was actually difficult. I got this one wrong. I put B. The answer is actually D. And let's take a look why. Okay, and so if we heated up 32 grams of this and we got 14 grams of this, which means that we have 18 grams of this, right? 32 minus 14, we get 8. Now 14.2 grams of this. Let's convert that to moles. So if I do 14.2 divided by the molar mass, I get 0.1 moles of that. I just said I have 18 grams of the water. If I convert that to moles, I get 1. And that gives us a 0.1 to 1 ratio. And so if I have 1 mole of this, there should be 10 moles of D. How many grams of sodium azide are needed to produce 68.1 decimeters of nitrogen? Let's start out with our 68.1 decimeters of nitrogen, and let's convert that to moles. And so to do that, I'm going to divide by the molar volume, which is SDP, which they gave me. So 68.1 divided by 22.7, it's about 3. Next, I can use the mole ratio to go from moles of this to moles of that. So divide by 3, multiply by 2, I get 2. Now I have 2 moles of this, and I need grams, so I'm going to just multiply by the molar mass. I get 130. See? A lot of guys had a hard time balancing this one. Okay, so normally I would try to balance the carbons first, but there's 2 sources of carbon, so it's difficult to do that. Same thing with oxygen. There's 2 sources of oxygen here. And so let's start with the hydrogens. I know that I need 12 hydrogens, and there are 6 in this molecule. So let's put a 2 here. Okay, that means I have 4 carbons here. I need 2 more carbons, so I'm going to put a 2 here. Okay, and so that gives me 4, 5, 6 oxygens, and that should be balanced. So this is 1, 2, 2, so that's a 5. That's B. What is the number of protons and number of neutrons in iodine? Iodine, you can look at the periodic table. Atomic number is 53, so it's either A or B. And the protons and neutrons add up to the atomic mass, which is shown here, so the answer is A. What is the electron configuration of a chromium atom? Remember, chromium is one of those exceptions. Okay. So remember, for chromium or for copper, so normally what you would do is like what they shown you in C, is where you fill up the s orbital completely and then you go on to the d orbital. Okay. However, remember that half-filled orbitals are more stable than filling this one up and only putting 4 here. Chromium and copper follow that rule, right? Where we've got the d orbital half-filled and we have the s orbital half-filled. Okay, and so that's the exception that they're testing here. The answer is D, 4s1 through d5. Which trends are correct across a periodic or period 3 from sodium to chlorine? Atomic radius decreases. Yes, it does. Here's atomic radius. Remember, as you go to the right, you're adding more and more protons, which are going to be pulling the electrons closer and closer. The next one, melting point increases. So what it'll do is it'll increase to carbon and then decrease to neon. So it goes up and then down. The reason carbon and silicon are so high, because remember they form those giant molecular structures. Okay. And the other one, melting. Yeah, so that was melting point. And then first ionization energy increases. Yes, it does increase. If you remember, ionization energy is the energy needed to remove a valence or outermost electron. But as you go to the right, there's more and more protons, and those protons are going to hold on to these electrons, have a stronger attraction for them. So it's going to take more energy to remove that the more you go to the right. So it was only 1 and 3 only, B. Which oxide dissolves in water to give a solution with a pH below 7? So pH below 7 is going to be acidic, okay? Now if you just look at your answer choices here, you've got these three are metal oxides and then a non-metal oxide. It's probably going to be D, okay? But you do need to know the formulas of the period 3 oxides when they react with water. Remember that metal oxides, when they mix with water, make bases. It's going to be above 7. And then nonmetals, when they react with water, are going to make acids, okay? Think magnesium hydroxide, a base, lithium hydroxide, calcium hydroxide, all bases. This one's going to make phosphoric acid, right? H3PO4. Okay, electronegativity values of the elements are given, and they want to know the increasing polarity of the bonds. Remember, polarity is all based off a difference in electronegativity. One atom is going to be hogging the electrons more because it has a greater attraction. Okay, so you just take each of the compounds and you subtract their electronegativities and see which one has the greatest difference in electronegativity. And so carbon and oxygen, oxygen and fluorine, nitrogen and oxygen, carbon, fluorine, and so the answer was C. Which compound has the shortest C-N bond? So you're looking for the strongest bond. The shortest bond is going to be the strongest bond. So you're probably looking for a triple bond here, okay? So nitrogen can make 3 bonds, right? Because it's right here in the periodic table. Fluorine can make 1 bond, oxygen 2 bonds, nitrogen 3 bonds. And so you're looking for a nitrogen that's only bonded to one other thing, because if it's only bonded to one thing, then that means it's using all 3 of its bonds on that one structure, okay? Because we're looking for the strongest bond, which is going to be the triple bond because it's the shortest. This nitrogen is bonded to 2 hydrogens and in a methyl group, so it's bonded to 3 things. So those are all single bonds. Same thing here, nitrogen is bonded to this carbon and then 2 hydrogens, so single bonds. Here the nitrogen is only bonded to a carbon, so that has to be a triple bond right there. Here the nitrogen's bonded to a hydrogen and it looks like a carbon. It's got a double bond and then a single bond. So the strongest would be C. Okay, hydrogen bond, remember, is a nitrogen, oxygen, or fluorine bonded to a hydrogen. So here's propane. Here's propanol. Here the hydrogen is not bonded to the oxygen, so this cannot do hydrogen bonding. Okay, it has to be a nitrogen, an oxygen, or a fluorine directly bonded to the hydrogen. Yes, this will have hydrogen bonding, right? We have an oxygen bonded to a hydrogen. Here we're going to have even more hydrogen bonding because this COO is going to kind of pull the electrons away from here. So the carboxylic acids are going to have the most hydrogen bonding. Okay, so this is propane, propanol, propanol, and propanoic acid. The answer would be A. Which statements are correct for metals? They conduct electricity because they have free-moving ions. Wrong. The metal ions are kind of stuck in these sheets, these layers. Okay, things that move around and conduct the electricity are the free electrons that are free to kind of move around. They consist of a closely packed lattice of positive ions with delocalized electrons. Yes, that's true. They are malleable because the layers of the positive ions can slide over each other. Yes, that's also true. So it's C, 2 and 3. Which statement is correct for this reaction? We've got iron oxide plus carbon monoxide. We're making iron and carbon dioxide, and we're releasing 26.6 kilojoules. So this delta H is for one of these reactions to happen. So if this reaction happens just like this, it's going to release this much heat. Okay. So if I'm just looking at iron, and I'm looking at 1 mole, so if 2 moles makes this much, then 1 mole is going to make half as much, okay? And it's going to be released because it's exothermic, evidenced by the negative sign. Okay, so they gave you these 2 equations and they gave you a target equation. They wanted you to manipulate these to make it look like that. So first thing I notice about my equation, the BRF is on the left side. Here the only BRF is on the right side. So let's flip that top equation, multiply by -1. Next, I need to cancel out, I need to cancel out the BRs, right? Because I don't see a BR in here. And I only need one BRF, so I'm going to multiply this one by half. And I only need one BRF3, so I'm also going to multiply this one by a half. And that makes it so that you get 3.5 of F2 up here and half of F2 up here, and when you add those together, they cancel out. So what did we do? We multiplied x by -1, and then we multiplied both of them by a half. The one that represents that is C. What is the enthalpy change in kilojoules the following reaction? This is going to be bonds broken minus bonds formed. So the bond's broken. We're breaking 3 of these hydrogens and 1 of these nitrogens. So 3 times 391 plus 945, that's the broken, minus the formed, we've got 3 NH bonds, but 2 molecules, so times 6, 391 times 6. They kind of flipped it, but the answer is D. Okay, the A is the one you would have chosen if you did formed minus broken. So it's broken minus formed. The diagram shows the energy profile for a catalyzed and uncatalyzed reaction, which represents the catalyzed reaction. Okay, so it's very important you do the catalyzed reaction because this big bump is the uncatalyzed, this little bump is the catalyzed. Okay, delta H, that's just saying the difference between the reactants and products. Here are the reactants, here's the product, so that one should be Z. And the activation energy is to the top of this hump, and it's for the catalyzed reaction, so it's X plus Z. So magnesium powder, excess magnesium powder was added to the beaker containing hydrochloric acid. The mass of the beaker and its constant was recorded and plotted against time. Which change could give line 2? First off, since you're using excess magnesium powder, changing magnesium powder is probably not going to do anything. We have to look at the limiting reactant, which is the hydrochloric acid. This is going to lead to the changes that we see. So you can see both of these are using magnesium rubrum, which had excess of, so it shouldn't really matter. Increasing the temperature is going to increase the rate, but it's not going to magically give you more reactions happening overall, right? Like you'll get there faster, but you'll still get to the same spot. So if it was just temperature, these lines would end up in the same spot, but they would just get there at different rates. So the only one that would make sense is using more hydrochloric acid, uh, a greater concentration of it. What happened to the pressure increase? So equilibrium based on pressure. Remember, you got to look at the moles of gas. You've got 1 mole of gas on the left and 0 moles of gas on the right. So you've got gas on this side, no gas on this side. So if you're increasing the pressure, if you're squeezing, well, then the gases are going to want to go this way. It's going to shift to the right, and it's going to make more hydrogen. More hydrogen means more acid. Acids decrease the pH, so it's A. 10 centimeters of aqueous sodium hydroxide, pH is 10, and then we're adding water, so that's 990. We're adding 990 centimeters of water. Okay, remember the pH scale is a logarithmic scale, base 10. So we're going from 10 centimeters, the volume is 10, and then we're going to bring the volume to 1,000 because we're adding 990. So 10 to 1,000 on the log scale is a factor of 2. So the pH should be 8. 10 to 8. Yeah. So it's kind of tricky. Which statement is incorrect for a 0.1 molar HCOOH? Remember, you need to know your strong and weak acids. This is a weak acid, meaning it partially ionizes or partially dissociates. Okay? And so D is true, partially ionizes. C is true. When this breaks apart, it's going to release 1H. It's going to be, it only partially ionizes, so yes, the hydrogen ion concentration is going to be less than 0.1. pH equals 1. That's only true if it's a strong acid. Okay? You take the negative log of this and you get 1. That's only if it's a strong acid, but since it's a weak acid, it's going to be greater than 1. This one should have been easy. What are the oxidation states of chromium in these two compounds? NH4 is +1, oxygen's -2, and so this should have been +6. So either B or C. Here, oxygen is -2, so it's -6, so these should have been +3, so the answer would have been B. Which of the following is a redox reaction? So we're looking for something that is one species that's gaining electrons, one species that's losing. This is going from 0 to, what is that, +2? So losing electrons there. This is going from +3 to 0, so gaining electrons, so there's your redox reaction right there. Okay, so we've got these electrodes. Which one's going to show up at the positive side for sodium chloride? So Na, sodium, is positive and chlorine is negative. So the one that's going to go to the positive side is the one with the negative charge. Opposites attract. So that's going to be chlorine. So it's either A or B. If we see, we've got molten sodium chloride that's Cl minus, and we're making chlorine gas. So we are losing electrons because we're going from negative to 0. So we're going to lose electrons. If we're losing electrons, it's oxidation. Oil rig. This is a major product of HCl and butene. Here's butene. Here's HCl. We're probably going to break this double bond and make a bond between this carbon and this chlorine and this carbon and this hydrogen. So you get this molecule right here, which is 2-chlorobutane. It's important to put the double bond here because if you put it here, that's but-1ene, then you would have gotten 1-chlorobutane. Which compound can be acidified with potassium dichromate? You're looking for an alcohol, but not any alcohol. You are looking for either primary or secondary alcohol. Tertiary alcohols cannot be oxidized. So this is an ether, this is an alcohol, this is an alcohol, this is a carboxylic acid. So it's either B or C, but C is a tertiary alcohol. See, it's got 3 here. Well, this one is a secondary alcohol, so the answer is B. Name this. So look at the longest chain. It's 1, 2, 3, 4. Meth, eth, prop, but. So this is butane, and we have an OH group on the second carbon and a methyl group on the second carbon. This will be 2-methyl-butanol. See, what type of reaction happens between alcohol and a carboxylic acid? Your OChem. This is you make an ester, so this is esterification. Remember, you need concentrated sulfuric acid to do this. How many structural isomers of C6H4 exist? There are 5. They're shown right here on the right. A lot of you guys drew some isomers like this. Remember, these are all the same. Doesn't really matter if you draw them like this. All of the bonds here are all the same. These are not different isomers. They're all the same. These, however, are all different isomers. There are 5, so B. Skip one. Okay, some of you guys missed this, and this was a pretty easy one. H1NMR shows the chemical environments. MS is mass spectroscopy, so that one shows the fragment patterns with the little pluses on the fragments. IR, infrared, shows you, that was like the strong or broad peak, or the short peak that shows the types of functional groups like the OH, the carbonyls, double bonds. Student performs an acid-base titration, forgets to calibrate it. Which type of error will occur? Okay, if you forget to calibrate it, that means it's going to be either high, it's going to be either always high or always low, which means it's systematic. Okay? Remember, you can't reduce random error, you can only minimize it by doing lots of trials, but systematic error you can fix by making sure your equipment is intact. So it's either going to be always high or always low, which means you have a lower accuracy. Okay? Lower precision, nothing here tells us it's going to be not as precise, but it's definitely not going to be accurate. So the answer is B. I know this was a lot, but here was the grade breakdown from this year's test. So you only need to get about half of them to pass. Here to get the 4, you only need 16. So hopefully with some studying, you guys can get to that point, and hopefully this helped.